So the next method that we will discuss is the Newton's method. The Newton's method. Newton's method is faster than the bisection method. And this method is easy and simple. So what are the steps in using Newton's method? So the first step is we pick an x, we pick a value of x which is close to the root, okay, which is close to the root of a continuous function f of x. Next step is we take the derivative of f of x, which is f prime of x. Okay, and the third step is we plug it into this equation. Plug into the equation x sub n plus 1 is equal to x sub n minus the function of x all over f prime of x, wherein f prime of x cannot be equal to 0 kasi magiging undefined yan. So kung mapapansin nyo, para siyang same as the fixed point iteration, yun lang, meron lang pinagkaiba dun sa equation na ginagamit. The last step is, syempre, we repeat the steps until it converges. So normally, ganun naman ginagawa natin. Repeat until it converges. Or yung ating x sub n plus 1 is almost equal or approximate to your x sub n. Let's say you have your example. You want to find the root of a function sine of cosine e raised to x. So, as mentioned earlier, the graph looks like this. So in this equation, or in this graph, this is the projected graph of this equation. Say you want to find the root of this equation. So we pick a value of x sub 1, say this value, x sub 1, and then we just get its slope. In calculus, when we get the first derivative of an equation, okay, we find its slope and therefore we draw a tangent line along the curve. Then we say pick an x value, say this, in this position, say this, x sub 2. Okay, so we pick next value, x sub 2. So we just erase this, and then we just get its first derivative. So we're just gonna draw a tangent line on this point here, and then we just pick x sub 3, say here, and then we just continue this method until our values, okay, become close to the roots. Let's say you want to find the roots of an equation, x squared minus a. In our calculators, we can find it easily, or we can say that the f prime of x of this is just 2x. And if f of x is equal to 0, therefore, we can say that x is just equal to the square root of a. Okay? And I think we can plug this into the equation of Newton's method. So saying that x plus n x over x sub n plus 1 is equals to x sub n minus f of x, which is x sub n squared minus a, all over the f prime of x, which is 2x sub n. So we can stop here and find the roots of the equation. But let's say that we're given an example wherein the function is x raised to 7 minus 1000. We cannot do this in our calculator because you will need uh, a higher version of your calculator so that you can solve this type of equation. But in numerical methods, we can solve this type of equation by using Newton's method. So if f of x is x raised to 7 minus 1000, therefore, if we get its derivative, we can say that it is just 7 of x raised to 6. And therefore, we can plug it into our equation. X sub n plus 1 is equal to x sub n minus f of x, which is x sub n raised to 7 minus 1000, all over f prime of x, which is 7 x sub n raised to 6. So in this method, let's pick x sub 1 is equals to 3. Okay? So by just substituting, x sub 2 will be equal to 3 minus 3 raised to 7 minus 1000. Okay? Over 7 multiplied by 3 raised to 6. And we'll get the value of x sub 2, which is equal to, so the value of x sub 2 will be 2.76, 7391, 730354.7. If we continue with our iterations, okay, I will not substitute the values, we can directly input it in our calcu. We can get the value of x sub 3, which is, so this is the value of x sub 3, 2.6900, 87, 40, 52, 645. And if we continue with our iterations, say we want to find x sub 4, the answer for this is, the answer will be 2.68, 27, 56, 44, 72, 616. And if we will try one last iteration for this, the answer will be, so the answer will be 2.68, 2695, 79, 93, 932. And I guess we can still try for one last iteration because we can see that we are nearing to the roots of the equation. So the answer for x sub 6 is, and the answer is 2.68, 26957, 95, 2797. And if you will notice that the first 8 decimal places of this equation, of the answers of these iterations are almost the same. So 2.68, 269,579. Therefore, we can say that this is the closest or the approximate answer for this equation. So that is how you do the Newton's method.